In this video we will see about Ohm's law. So according to Ohm's law, the current flowing through a conductor, suppose you can assume a conductor is there and which is having length L, area cross section A. They apply a potential difference across the conductor. The current flowing through the conductor is directly proportional to potential difference across the conductor. And to remove that proportionality, they use a constant, that is G. So G is called conductance here. G is called conductance. Reciprocal of conductance, what do you call resistance? That's why in place of G you can take 1 by R. So I is equal to 1 by R into V. So V is equal to IR. This is the Ohm's formula. V is equal to IR. V is potential difference or voltage. I is current. R is resistance. What is unit of resistance based on scientist name Ohm's? So they put a unit of resistance is Ohm, and this is the symbol for Ohm. Reciprocal of Ohm, they write spelling reverse for the unit of conductance is MHO, mho, or Siemens. And here you see how a resistance depend upon what factors. Resistance of the conductor depend upon the length, more resistance, more area, less resistance. So resistance is directly proportional to length and inversely proportional to area of cross section of the conductor. And of course it depend upon temperature and it depend upon impurity added and nature of the material also. So here to remove this proportionality they use a constant rho. Rho is called resistivity or specific resistance. So specific resistance means what do you say? It is the resistance of the conductor which is having unit length and unit area of cross section. So units of resistivity is ohm meter we get as, that is L is meter, A is meter square. So meter into ohm meter we get unit of resistivity. Reciprocal of resistivity or reciprocal of specific resistance you can call conductivity, represented with sigma. Conductivity 1 by rho. What is the units of this? That is a mho meter inverse, or mho we can write as Simon meter inverse. That is the unit of conductivity. Here four quantities: resistance, ohms, conductance, Simon or mho, or resistivity or specific resistance, ohm meter, and now specific conductivity or specific conductance or conductivity. That is a mho meter inverse R and Simon meter inverse. These are the units. Main important here relation between potential and current. V is equal to IR, and after that resistance R is equal to rho L by A, and rho is called resistivity or specific resistance. Relation with conductivity, sigma is equal to 1 by rho. Now we'll see about a drift velocity. The average velocity of charges dragged through the conductor, what we call drift velocity. Suppose for example you can take a conductor is there and conductor having certain length L, area cross section is A. They apply some potential across that. Due to potential we get field intensity. Suppose the field intensity we have one relation that we get in electric potential concept. So potential by length of the conductor. Potential difference by length of the conductor gives field intensity. Or you can say potential difference for unit length. So here due to this field, that field you can think it is acting like this. A charged particle is there. What is the force experience? F is equal to EQ. What is acceleration? Force by mass, that is EQ by M. That means a charged particle is moving with some acceleration when you apply some potential across the conductor. Acceleration means what happens? Speed keeps on increasing. Speed keeps on increasing and that accelerated motion. But here when it is increasing its speed, it may maybe take collision with other charge carriers which are moving randomly here, and maybe take collision with the atoms of this material. Because of that, what happen? The gain velocity will be lost and loses loses its kinetic energy what it gains. That means every time what happened, because of field it is accelerating, and due to collision it loses energy. So then what happened, and an averagely with what speed it is moving. Of course, at any instant if you check the different velocities it moves, but on an average with what velocity this charged particle is moving through the material, through the conductor, that what you call and drift velocity. So here in definition they mention that the average velocity of charge dragged through conductor. Why they mention dragged through conductor? And this electron or some charge carrier that is moving from one end to other end, it may take number of collisions with the other charges and maybe number of collisions with the atoms. So due to that, this particle is dragged through the material due to electric field. That's why they call here drift velocity is dragged velocity inside the material. Suppose for example you can take for unit volume. If you assume for unit volume inside, how many number of charge carriers is there for unit volume? That here number of charges within unit volume, and that is more for good conductors and that is less for insulators. Semiconductors we have an average value. More free charges is there and more electrical current flows here. So how many such charges are there in the whole material? That means the number of charges present in the material is N is a number for unit volume, and what is the volume of the conductor? Area into length. This many charges are there. What is the total amount of charge? Total amount of charge is NAL is total number of charges into charge of each one is E. Take that electron is moving. So charge of each particle is electron, that you can consider electron is a particle, and total number of charges are present. N is for unit volume into total volume. So you get total number of particles into charge of electron. What you get total charge we get. Consider that from here to here it takes t seconds to move the charged particle from here to here. What is say drift velocity? Drift velocity is total length by total time. How much distance it travel? T distance it travel. So L distance it travel within t time. So L by t is drift velocity, you can write. Now how to calculate current? Current is equal to charge by time. Charge is total charge NA LE by time t. What is L by t? L by t we can write NEA VD. VD is drift velocity. A is area of cross section of the conductor, and E charge of each charge carrier. Here we are taking electrons. That's why we can take E, and N is charge density. Charge density means for unit volume how many charge particles are there. That gives current I is equal to NEA VD. That is drift velocity. You see here, and conductor they apply some potential. Here current I is equal to NEA VD. And here current density. Next current density. Current density means for unit area how much current is flowing through the conductor. So the amount of current flowing through conductor for unit area normal to cross section. So current by area. So current units are ampere and area is meter square, ampere per meter square. It is a vector quantity, so you can write here, and this current density represented with J, so that is I by A is equal to NE VD. Why? Because you know current I is equal to NEA VD, and divided by A is there, A get cancelled, and you get NE VD V8. And after that we'll see about mobility of charge carrier. Mobility. What is mobility means? The drift velocity gained by a charged particle when we are applying unit electric field intensity. Mobility is equal to drift velocity by electric field intensity we can take. We know that electric field intensity is equal to V by L or V by D. So that formula we are using here, electric field intensity is equal to V by L. V is equal to IR according to Ohm's law. Just now only we discussed. V is equal to IR according to Ohm's law. So here what you can write I value. I value is using drift velocity formula, that is I equal to NEA VD. We can substitute here. In place of I is equal to NEA VD. and here into R. R is nothing but resistance. Using Ohm's law, we calculate here what is the resistance formula. R is equal to rho L by A, or otherwise we can write rho as 1 by sigma we can write. That formula we are using here, and here you see E is equal to V by L. V is equal to IR according to Ohm's law, and I is NEA VD using drift velocity relation, and R is rho L by A. Here L and A get cancelled, numerator and denominator. What do you get? NE VD we get. That is field intensity E is equal to, you can write like this, NE VD into rho, resistivity. From this equation and according to definition of the mobility, what is mobility? That is drift velocity when you are applying unit electric field intensity. So VD by E, substitute this E value here. So VD get cancelled and you get mu, or nothing but mobility of the charge particle is 1 by NE rho. And rho we can write reciprocal, no? Rho we can write reciprocal of rho is sigma. So sigma is equal to, send this NE that side, what you can write? Sigma is equal to 1 by rho, that is equal to mu NE. Mu is called mobility of charge carrier. N is charge density, means how many number of charges are there for unit volume, and E is charge of the electron here. Why? Because here charge carriers are electrons only. So electron charge only we have to take here. Okay. Here important formulas: current and drift velocity relation, and current density and drift velocity relation, mobility, and here mobility, drift velocity relation, mobility conductance, and mobility resistivity relation. Suppose if you take in case of semiconductors, what we can write? Semiconductors has two types of charge carriers, and normal conductors means only we are taking electrons. But here in case of semiconductors, two types of charge carriers are there. Those are electrons and holes. And if suppose electrons and holes has mobility mu E and mu H, and their conductivity is sigma E and sigma H. Then what is the conductivity formula we get here? And suppose n number of charge carriers is there for unit volume. Yes, mu Ne. This is a conductivity formula. But there you can write for electron separate, for hole separate, both you can add. What is the total conductivity of the semiconductors? Total conductivity of the semiconductor is conductivity due to electrons, conductivity due to holes. For both hole and electron charges are same only, amount is same only, but one is positive, other is negative. So you can take E common, and Ne is number of electrons present for unit volume, mobility of electron plus number of holes present per unit volume into mobility of hole. Suppose there are three types of conductivity is there for semiconductors. One is intrinsic semiconductor. Intrinsic semiconductor means number of electrons, number of holes, both are same, which is equal to Ni. So in place of this, Ne and H both is replaced with Ni, that you take common. So what you get, and conductivity of intrinsic semiconductor, sigma I is equal to E into Ni. So charge common and number of charges also equal for both, and to mu electron plus mu hole, mobility of electron plus mobility of hole. Suppose if you take p-type semiconductor, number of holes are much greater than number of electrons. So remove that electron number, take only number of holes. So this you can put 0. Then in that case what you get? Sigma p is equal to, that is positive type semiconductor. That's why they mention here sigma p. In p-type semiconductor, the conductivity is number of holes in for unit volume into mobility of hole into charge. In n-type what you get? Number of electrons into mobility of electron into charge we get. So this is about conductivity of a semiconductor. This is general formula for pure form, nothing but intrinsic, and both are having same number, Ne and H both are same, take common. Suppose if you take p-type, NH is much greater than Ne, put Ne equal to 0 in the equation. Suppose in n-type, electrons are much greater than holes, so put NH equal to 0 in this equation. Like that, we can calculate resistivity of semiconductors in three different cases: intrinsic, N-type and P-type semiconductors.